Okay, Algebra 1, the last one that we're going to do in Chapter 8. Some scientific notation 8.4 is where we're at, which is on page 512 in your book. Alright, so scientific notation is, actually, here, why don't you just combine your key vocabulary and your key concept together, because here's the definition. A number written in scientific notation when it's in the form c times 10 to the n, and I can't put any exponents, I got to remember to put there, where c is between 1 and 10. Okay, so you take a number and you make it into a whole number between 1 and 10 by moving the decimal, and then n is the number of places you move the decimal. So here is an example. 2 million. Here is 2 million in what we call standard form. So scientific notation would be 2 times, and I'll show you where I get this from in a second, 10 to the 6th. To make it between 1 and 10, you move the decimal until it becomes a number between 1 and 10, and that's 2. And we moved it 6 places, so 2 to the 6th. And also with decimals, we would move this one this way, though. Notice we're moving it this way, so it'll be 5 times 10 to the negative 3 in that case. So let's do these. Here, I need to make this a number between 1 and 10, and I don't really, you know it's going to go right there. So you gotta put it, as long as there's numbers, you got to put them. 2, 5, 6, it's the zeros you can drop, times 10 to the 7th, because we're moving it 7 places. That's it. This one, we're moving it the opposite direction, so it's going to be 5.74 times 10 to the negative 1, 2, 3, 4, 5, 6, 10 to the negative 6. 5 or 6? 1, 2, 3, 4, 5. Ooh, I only moved it 5 places. Okay, negative 5. So write the number in standard form. This is just the opposite way, so we're going to move it 6 places. 1, 2, 3, 4, and then 2 more zeros, so 0, 0, 7, 5, 0, 0. Put your commas in so it's easy to check at 2,007,500. This one, we're going to move it opposite direction, so 3 or 4, 1, and add 3 zeros. 1 and add 3 zeros. 1, 2, 3, 1, 6, 8, 5. Or you could just do all the loops and fill them in, whatever's easiest for you. Okay, write the number in scientific notation, then write the number 4.5, 10 to the 4th in standard form. Okay, so 530, so it's going to be 5.39 times 10 to the 6th, and 4.5, 4 places, 1, 2, 3, 4. So there's the scientific notation. They say, oh, it's not 6. Boy, I need to quit. I'm doing too much. 10 to the 5th. 1, 2, 3, 4, 5. Oh, yeah. Okay. Let's see if I got this one right. Yes, I did. Okay. Order from least to greatest. Well, this one, you know what? I'm going to go ahead and just do this one back out. 7, that's 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7, since all of them are in the other form. So this is 780 million, 80 million, 103 million. So this is the least right here. This is the next, and this is the biggest. And I'm just doing it a little different, I guess. I know it's scientific notation, but so there were the numbers, and that's the order I had them in. All right, example number 4. Evaluate the expression and write your answer in scientific notation. Now what they're having us do is they're having us multiply 2 numbers that are written in scientific notation. Here is one and here is the other. So all you do is multiply the decimal with the decimal and the exponent with the exponent. So you just take 8.5 times 1.7. So that's 5, 3, 56, 59, add a placeholder, 5, 8, 5, 14, carry the 1, 8, and 4. So 2 places. 14.45 times 10 to the, remember when you multiply exponents, you just add the exponents, 10 to the 8th. Write your answer in scientific notation. Now this is not in scientific notation because this number is not between 1 and 10. So we still have to go back one place, so it's 1.445, and we just added another decimal place, so we just add to that. I'm going to see if I did my multiplying right. I did 14.5, and then you had to move it back. Okay? So to the second power means we multiply this times itself, so it's 1.5 times 10 to the negative 3 times 1.5 times 10 to the negative 3. Pen doesn't want to work for some reason. So 1.5 times 1.5, which I'm going to do that with my calculator. So 2.25 times 10 to the negative 6, because you add your exponents. And that is in scientific notation because 2.25 is between 1 and 10. Okay, and then dividing, you do the same thing. You divide these two. So it'll be 1.2 divided by 1.6 is 0.75, and then you subtract the exponents. 4 minus negative 3 is positive 7, so times 10 to the 7th. We move it, this isn't between, so it's 7.5, and since we went this way, it takes them off 10 to the 6th. Let's see, and does take it off. Okay, so order from least to greatest. So I'm looking at, I'll write this one in scientific notation, so it's going to be 2.75 times 10 to the 4th. So we look at the powers. The 10 to the 5th is the biggest one, so that's the greatest number. These have the same power. 3 is bigger than 2, so this is the smallest. This is the next, and then that one is the biggest. So the smallest is that one. Yep. Evaluate the expression. So you can do another way is just take everything to the second power right here. So 1.3 to the second power times 10 to the negative 10. So 1.3 times 1.3 is 1.69. times 10 to the negative 10, and that is in scientific notation because that's between 1 and 10. So now we divide. 4.5 divided by 1.5 is 3, and then we subtract, or the negative just goes up and joins that one, so times 10 to the 7th. Number with number, multiply 1.1 times 4.2, which is 4.62 times 10 to the 9th. You add those exponents. All right, example 5. We'll just keep on going here. Seems like we have lots of examples. Blood vessels. Blood flow is partially controlled by the cross-sectional area of the blood vessel through which the blood is traveling. 3 types of blood vessels are venules, capillaries, and arterioles. There's the radius of each of those. Let R1 be the radius of the venule, let R2 be the radius of the capillary, or let the ratio of R1 to R2. What does the ratio tell you? Okay, so R1 to R2. So let's see on the solution. R1 and R2. Okay, there's R1 and R2. We're supposed to write that as a ratio, so we write that on top of each other. We simplify that. So in simplifying that, you would divide these out and then simplify. So it's 2, the ratio tells you that the vennule's radius is twice the capillary's. Wow. So I'm just this right here, to find the cross-sectional areas, use the formula for the area of the circle, pi r squared. So what they did right here, which is kind of cool, when they're comparing the areas, look at the pi's cancel out, so you don't have to deal with it. So you just have to square each one of those, and then crazy. So let's look at the guided practice. Compare the radius in the cross-sectional area of an arteriole with the radius in the cross-sectional area of a capillary. So you would be able to write the radius of the area of an arteriole. Arteriole would be 5 times 10 to the negative 1 compared to the capillary, which is 5 times 10 to the negative 3. And compare the area. Let me go back to that 1. You would square both of these. Squared. So those would still cancel out. This would be 10 to the negative 2 over 10 to the negative 6. This one, negative 2 minus negative 6, boom, boom, would be 10 to the 4th. And I'm totally following it's exactly what they asked me to do in B, and I just put in those formulas. Look at that, 10 to the 4th. All right, so it's just writing ratios and simplifying. So I don't think you're going to be asked to do anything like that, so don't stress out about that too badly. And I think that might be it for scientific notation. We'll talk to you later.